Hello friends, the concept we are going to discuss is root cause of a magnetic property, and that also we'll understand without any mathematics, and for that we'll take help of a few concepts which we have learned already. One concept is force on a moving charge of a magnetic field, which is F is equal to Q V cross B. Then magnetic field due to a straight conductor of coil carrying current. See, if a current is flowing in a certain direction, then if we'll keep our right hand thumb rule, the direction in which the fingers are curled is showing the direction of a B. But vice versa also is true. At the same time, if the current is in the form of a coil, then your fingers, curling fingers, will show the direction of current, and thumb will show the direction of the magnetic field action. Okay. Now, force between parallel conductors carrying current. If you are taking two conductors, if those are the currents flowing in the conductors are in the same direction, they are getting attracted. And we have also seen that if the currents are flowing in opposite directions, those are getting repelled. Similarly, if we take two coils, in the coils, if current is flowing in the same direction, the coils will be getting attracted because these are parallel to each other. And if the currents flowing in the coils are in opposite direction, they will get repelled by each other. So this concept also we have studied. Depending on these concepts, so we are going to investigate into what is the root cause of the magnetic property of a magnet. Okay, let us say this is a magnet. This is made up of molecules, and ultimately those are made of atoms. Let us say it's millions and billions of atoms will be there, but for a clearer understanding, let me show only this tip, which is made up of 4 atoms. Let us say in every atom at the center, the positive charge is concentrated, and on the outermost cell, electrons are flowing. This you know already. Let us say there are 4 atoms only. So on the outside of this, electrons are flowing. So here electrons, let me show it in a different color. Here electron. Now what is a magnetic material? Magnetic material is that in which all the rotations of electrons are aligned in the same direction. That means, let us say if the electron is passing in this direction, and this also electron is going anti-clockwise only. In the next atom also electron is revolving anti-clockwise only. All the electrons are revolving in anti-clockwise only. In fact, in general objects, in this duster, it's not magnetic in nature. That's why it is not aligned. But in magnetic materials, especially in magnets, it is exactly aligned, all the things. So now here you imagine that there are 4 atoms, and all the 4 atoms are aligned. All are in this direction only. Let us say electron, the motion of a charge only is a current, right? So electron is moving in this direction, here in this direction, here in this direction, here in this direction. Okay, and of the second loop, let us say this is the first atom, this is second, this is third, this is fourth. Our second, again show this with the, let me show it with a different color. This is coming like this is coming like this, again in anti-clockwise direction. Okay, and third, it is coming like this, like this, like this, like this. In fourth, like this, like this, like this, like this. Here you can clearly see, here though all were in anti-clockwise direction only, these two are opposite. The currents are flowing in opposite direction, so they will cancel out each other. You can eliminate it. Here also they are cancelling out each other. You can eliminate it. Here also they are cancelling out each other. You can eliminate it. Here also they are in opposite direction. You can eliminate it. So though the electronic currents are in this direction, here also it is flowing, but the net effect is it is cancelled only the outer terminal. It appears as if in the outer line only current is flowing. Okay, and we have learned that if there is in a coil form, if current is flowing, magnetic field will be in this direction, perpendicular to that. See, if this is the coil, if in the coil, if this is the current direction, then magnetic field will be perpendicular to that, right? So from here outside, so this will be the magnetic field. Now the same thing you imagine with this thing, you imagine with this is one slice, this is a square, another square, another square, another square, like that. Infinite number of squares are there, like that you can imagine. That means for another line, again current will flow like this and will go like this, and another line current will flow like this, like this. So for all these things, little b, all b's are in the same direction, right? So they will be added up. B is magnetic field induction, is a vector quantity, all are in the same direction, so magnetic field induction will be added up. Yes or no? Now let us understand it. See, this is the thing. Let us say that current is passing like this, okay, like this, and it is coming like this. The edges I am showing like this edge I am showing, it is coming like this here and coming like this. So it is flowing. In the next slice, you think current is coming like this, wait and back, otherwise here it looks like this. The current will flow like this, will continue, will come like this, right? And you can think of another. See, there are infinite number of like this. I am just showing 3 4 to make you understand. It will come, it will be continued like this, right? Now see, generally magnets are having north pole and a south pole. What is called north pole, what is called south pole? See here, if you turn this in the left, it is the anti-clockwise direction, right? If it is anti-clockwise direction, it is coming out of you. This is called north pole, okay? And see, this is anti-clockwise direction, it's a north pole, and here also it is like that only. So this is coming in this direction, so this side is called north and this side is called south, okay? Of a bar magnet, if you are considering one bar magnet, one side will be north, one side will be south. So always we say that from north magnetic field lines are coming out, into south it is going in like this. And we also say that unlike poles attract each other and like poles repel each other. But those poles and whatever you have studied from your earlier classes, so we are talking of the root cause of that magnetic property. Why actually it happens? Let us see. So another line will come like this. The coil, actually huge number of infinitely large number of coils are there like this, like this, like this, like that. It is going. Slices of squares are there. I'm just showing 4 5 1 2 3 4 5 to make you understand. That's it. Like this is going. So here, if it is being curved, let me name it as, see, it is like this, it's coming, let me name it as a north. Now see, this is purely one convention, okay, and this is generally assumed to be north, right? So we are showing north, and I am going to show you that even if we will take a south, then also it will work. Only we are giving, for our sake of a convenience, we are taking it as a north. But if we take south also, it will work. How work, we will show it. Now see, this is north, so this side is a south, okay. Now I kept it this side. Let me make a show it the same thing with a different color. This magnet. Now let us say this magnet also is aligned like this, and with this concept only. Let us say this is coming like this, and that is being continued like this. Is it visible? That is coming. So it is coming like this, and again it is from this side to this side it's coming. So anti-clockwise I turned, so this side is north. So from anti-clockwise, from where the B is coming out, that I am taking as north. Now that's my convention. So if I call this north, this side will be south, right? Now see, if you bring this towards this, what will happen? If you bring this towards this, what will happen? You can see this current and this current, these are in the same direction, yes or no? Now force between parallel conductors carrying current, this thing we have seen while discussing this, that if the currents are in the same direction, they will attract each other, and since the currents are in the same direction, they attract each other, okay? But if I bring this side towards this, the currents are in opposite direction, that's why they will repel each other. Only because the currents are in opposite direction, they are repelling each other. But what we are saying is, see, this is our assumption that we said this is north and this is south. If north is coming towards south, we say these are opposite poles, that's why they are attracting each other, like this we say. But actually what is the root cause? Root cause is, since the currents are in the same direction, they are attracting each other. And the pole what we have taken is purely our assumption we have taken, and we see that opposite poles attract each other, we see, and it's okay to conclude that way. But most of the times, so students are thinking that there are poles inside this and opposite poles are there due to some mysterious force. Due to some mysterious force, opposite poles are attracting each other, and due to some mysterious force, like poles repel each other. They think like that. But it's no pole, nothing is there inside like this. Actually what is happening is, only when the direction of currents are in the same direction, they attract each other, and if the direction of currents are in opposite direction, they repel each other. And that happened to be, if the same poles are coming closer to south are coming, then they repel each other. And if north to south, if you bring north to south, the currents become in the same direction, that's why they attract each other. Now this assumption we will change a little, and let us see the same thing happens or not. See, this was north, right? This north I made south. Now all the norths I am making south. So if I make the north south, it was south and now it became north. Here it was south, so I made it north, and it was north, so I made it south. Now see that now also, if we bring north together, what happens? The currents are in opposite direction. It's not that north pole is repelling north pole. Since the currents are in the opposite direction, they repel each other, okay? And you bring south, the same thing. Since the currents are in opposite direction, they repel each other, and it's south. What we are saying, that opposite poles attract each other and like poles repel each other. If you bring north south together, what will happen? Currents are in same the direction, that's why they attract each other, and those are south and north, okay? Since these are in the same direction, that is the reason, that is the root cause of attraction between the opposite poles. The poles are some concept, just a concept which we gave as per our convenience. So opposite poles always attract each other, and like poles always repel each other. What we say, that is true, but the pole concept is our giving. But actually what happens in the construction of the magnet is, when we bring like poles, so why they repel each other? Because the currents are in opposite direction. And when we bring south towards north, why they attract each other? Because the currents are in the same direction. Hope it's clear to everybody. So the final line is, the root cause of a magnetic property, when we look into it, the root cause is the electricity is the root cause of a magnetism, in fact. That's why the electromagnetism branch is developed. It is not electricity separate, magnetism separate, magnetic force, electric force, like this we were talking. But at a point we realized that electric force and magnetic force are two aspects of the same entity, okay? So the pole concept is a human made concept for our understanding sake, but actually the directions of currents aligned are responsible for attracting and repelling each other. Hopefully this concept gave you a very clear understanding about the poles of a magnet, how real are the poles of the magnet, and what is the reason that magnets attract another magnet if a particular poles are coming near to each other, and why like poles if are brought near each other they repel.